Welcome you all. In this session, we are going to discuss mod modified Euler method for finding the solution of swing equation in power system. Outcome: after successful completion of this session, the student would able to solve swing equation using modified Euler method. So, the swing equation which we saw in the previous session can be solved by numerical iteration methods. The methods used to solve swing equations are: first one is modified Euler method and second one is Runge-Kutta method. So here in this session we are going to discuss in detail about the modified Euler method. Numerical iteration techniques can be applied to obtain approximate solution of nonlinear differential equation. Euler's method is the simplest method. Consider a generator connected to infinite bus through two parallel lines and a three-phase fault occurs in the middle of the line. Then, so how we are going to solve? So to solve this can be done by using the first derivative of initial point. Next point is obtained. Xip is equal to x naught plus dx by dt into del t. The step T1 is equal to T naught plus del T. Using this x1p dx by dt at x1p is equal to is a function of T1 x1. So x1 of p is equal to x naught plus dx by dt of x naught plus dx by dt of x1 divided by 2 into del t. Similarly, xi plus 1 is equal to xi plus, just I have to replace this uh, 1 by I plus 1. So this naught is the previous case. So it is xi. So here x naught becomes xi and xi becomes xi minus 1 by 2 into del t. So input power Pm is constant. So at steady state Pe is equal to Pm. So del theta is equal to sine inverse of Pm by Pmax. So Pmax is equal to Ev by X. X is the reactance. At synchronous speed del omega naught is equal to 0. At synchronous speed del omega naught is equal to 0. So P2 max is equal to Ev by X2. Ev by x2. So we know the swing equation is h by pi f naught d square del by d dt square is equal to pa, which is equal to, that is the accelerate net power, which is equal to pm minus pe, right? So now just what you have to do is bring h by pi f naught to the other side. So you'll be getting d square del by dt square is equal to pi f by h Pm minus P2 max sine del, which is equal to Pm minus P2 max sine del is nothing but Pa. So you can replace the term by Pa. So the expression becomes d square del by dt square is equal to pi f naught by h into Pa. And d del by dt is nothing but del omega. So now I am replacing it. So my equation becomes d by del omega divided by dt is equal to pi f naught h Pa, which is equal to d square del by dt square. Applying modified Euler method to the above equation, T1 is equal to T naught plus del T. So del I plus 1 is equal to del I plus d del by dt into del T. So del omega I plus 1 is equal to del omega I plus d del omega by dt at del T. The derivatives at the end of interval is given by, iteration is given by d del by dt at del omega p I plus 1 is equal to del omega I plus 1 p. So the corrective value is corrected value is del I plus 1 is equal to del I plus d del by dt of del omega plus d del by dt at del omega I plus 1 the whole divided by 2 into del t. So similarly del omega I plus 1 is equal to del omega I plus d del omega divided by dt plus at of del I plus d del omega by dt of del I plus 1 the whole divided by 2 into del t. So this is how we solve the equation using modified Euler's method. Thank you.